Now, check this out. We're almost done. We got one last thing to say today. One last thing to talk about. Now that Galileo has proven that the planets orbit the sun, because you can just watch them go around the sun, does that explain why? Does that explain why the planets orbit around the sun? No. Doesn't have proof yet. We still hadn't figured out why the planets don't just fly away? Why are they stuck orbiting the sun? And some of you have actually already mentioned why, but we didn't figure that out yet. And it wasn't until this last person came along who finally figured it out. And that's this guy right here. And if you're following along in your book, everything I've talked about so far about the history of astronomy was in chapter 3. This guy, they put him off in chapter 4 for some reason. Okay? Does anybody know who this is? Who's this right here? Rocking this amazing, like, Captain Hook hair right here. This is Isaac Newton, right? This is Newton. Newton was the one who figured out why the planets do what they do, okay? He's famous for discovering... The answer is gravity, right? Gravity is why all of the orbits work the way they do. It's why the planets orbit the sun. And in fact, Newton is famous for inventing gravity or discovering gravity. Well, clearly he didn't invent it. It's just a physical thing, right? Did he discover it, though? No. Everybody's been dropping stuff for a long time. We knew about gravity. Like, the story is that an apple fell on his head, and that made him realize, oh, gravity. Does that sound like a thing that actually happened? Does the apple story really sound like it happened? Because, spoilers, that never happened. That's just a nice little fairy tale that we tell about Newton. It's not true, okay? So it wasn't that he discovered gravity. It was that he figured out how gravity works. In a way, he understood gravity better than anyone else. So let's get this out. He came up with our final law, okay? Final law, which we call the Law of Universal Gravitation, okay? The Law of Universal Gravitation, okay? Now, here we go. Here's what the Law of Universal Gravitation basically says. Number one, up until this point, people thought that only Earth had gravity. According to the Law of Universal Gravitation, what has gravity? What has gravity according to Newton? What kinds of things have gravity? It's not just the Earth. Give me some things. Basically, everything that has mass has gravity, okay? So not only does the Earth have gravity, but the moon has gravity, and the planets have gravity, and you have gravity. I have gravity. And importantly for us, the sun has gravity, right? He was the one that figured out that the sun has gravity. But that's not the whole law, okay? It's not the whole law. Because check it out. Does everything have the same amount of gravity? Do you have the same amount of gravity as the Earth? No. You have way less gravity than the Earth. So the way it works is the more mass something has, the more gravity it has, okay? More mass means more gravity. So the Earth has a decent amount of gravity because it has more mass. Why does the moon have less gravity than the Earth? Why does the moon have less gravity than the Earth does? It has less mass. It has less mass, a smaller mass. Yes, that's correct. So, with this in mind, why does everything orbit the sun? Why is it that everything orbits the sun instead of the Earth? It's a pretty simple reason. Why does everything orbit the sun? It has a lot more gravity because it has a lot more mass. That's correct. You guys are getting all the parts of it. So the sun has way, way, way more mass than the planets do. And so that's why it's able to keep everybody orbiting it. It's not even close. If you took all the planets in the entire solar system and squished them together, that would still be less than 1% of the mass of the sun. The sun is ridiculously large. So the sun has a ridiculous amount of gravity. That's why everybody orbits it. But that law of universal gravitation is not quite done. So first thing, law of universal gravitation says everything with mass has gravity. More mass means more gravity. But there's one last thing that law says, and I'll repeat all that at the end of the video. So here we go. The last, very last thing is about distance. And this was the real important discovery here. Up until this point, people thought Earth's gravity went on forever. No matter how far away from the Earth you got, you'd always feel the same strength of gravity from the Earth. But Newton was the one that figured out that if you get farther away from something, if two objects get farther apart, what happens to the strength of the gravity between them? What happens to the strength of the gravity between two objects as they get farther apart? So if you go away from the Earth, what happens to the strength of gravity you feel? Yeah, it's less and less and less. So if you increase the mass of an object, its gravity goes up. But if you increase the distance to that object, the strength of gravity goes down. It's kind of like magnets. The farther away you are, the less you feel, right? And that almost fully explains Kepler's laws. Because remember, Kepler's second law and third law both said that if you are farther away from the sun, what happens to your speed? If you're farther away from the sun, what happens to your speed? If a planet is farther away from the sun, is it faster or slower? Here we go. Slower. Yes, it's slower, right? The farther away a planet is, the slower it is. And that's because of the way gravity works. Why, according to gravity, why would a planet that's farther away from the sun move slower? Why would a planet that's farther away from the sun move slower in terms of gravity? Because it's farther away, it's going to feel less gravity from the sun. The sun is not pulling those planets that are way out on the outer edge as hard as the planets that are really close to it. So the reason Mercury goes so fast is it feels the strongest pull from the sun. But Neptune way out here, because it doesn't feel very much gravity from the sun, goes very slow. Does that make sense? Yay! So let me put all of that together. Newton's law of universal gravitation says everything with mass has gravity. More mass means more gravity, but a bigger distance means less gravity. Okay? And that, right there, Newton's law of universal gravitation, we still use his equations when we're sending astronauts out into space. So we bet astronauts' lives on the universal law of gravitation. So Newton is correct enough to base people's lives on it. That's not the end of the history, but that's all we're going to talk about it for right now. And that's all we're going to talk about it for the next few weeks. Because the next major discovery that we're going to have to add to this timeline was when Einstein came along. And Einstein stuff gets crazy. We're going to talk about the theory of relativity eventually. That stuff's going to be really fun. Way more interesting, in my opinion, than all of this stuff's been. And we'll get to talk about time changing and all kinds of cool stuff. But we'll get to that,